So today I want to show you how to model an end-to-end supply chain in Microsoft Excel. We'll keep it pretty simple, but I will have enough little complexities added to it so that you get something out of it. So if we take a look at what the supply chain looks like that we're going to try to model, it's pretty straightforward. It starts with the production of the active ingredients. So really what we're going to be looking at here is, let's say, a pharmaceutical. And we'll choose a product that has a 5 milligram tablet. And we'll make this up as we go in the model so you can see how you actually go about creating it kind of in a live fashion. But we'll start with the active ingredient production. That'll then flow to the bulk manufacturing step. So we're taking the active ingredient and we're going to be pressing it into a tablet. From there, it will then move on to two different packaging operations. Let's say one packaging operation located in the United States to service the US market. And then we'll have a European packaging location that in our case will just service Germany and the UK. So it's very simple. We're talking about 3 markets, 2 packaging sites, 1 bulk manufacturing site, and 1 active ingredient. And again, we're going to be talking about just 1 dosage form for this particular pharmaceutical. So it should be pretty simple. All right, before we get started in Excel and modeling, I just want to go through some of the general characteristics of what we're going to try to model here. So at the very top of this slide, you can see we're going to model in monthly buckets over a 3-year horizon. So it's going to be pretty high-level planning, but it'll be enough detail that you can get some key takeaways on the supply chain. The safety stock calculation that we're going to use, or the inventory coverage calculation that we're going to use, is going to be based on consumption of forward-looking requirements. So you'll see that when we get to modeling, but we're not going to be using kind of an average formula of forward-looking demand or something like that. We actually are going to use a consumption-based algorithm. Because we are planning at a high level, we're going to assume transportation lead times are factored into the other operations that are modeled. So we're going to assume that if something ships in 1 month, it arrives at the receiving location in that same month. So we're not going to get down to the level of detail of modeling, let's say, 1 week of transportation lead time or something like that. We are going to calculate the inventory values at each level of the supply chain, so you'll be able to see what the working capital that you have tied up in, let's say, finished goods or bulk manufacturing or active ingredient manufacturing happens to be. For a pharmaceutical supply chain, expiration is something that is critical to model. We're not going to do that in this example. We'll do that at another time. It's a rather straightforward thing to layer onto the supply chain model, but we'll leave it out for today. And then in terms of our operations, all the lead times are going to be rounded to the nearest month. So if something takes 3 weeks, we're going to assume it takes 1 month. Since we're going to be planning in monthly buckets, it makes it easier to just round to the nearest month. In terms of finished goods, it's going to be a common strength and a common active ingredient. So we're going to have 1 location that manufactures the active ingredient, and we're going to have just 1 strength that we're talking about. So the example we'll use will be a 5 milligram tablet. Our safety stock targets for the different finished goods are going to be between 2 to 3 months, and we'll just make some different numbers up as we go. On the packaging operation, the lead time we're going to be talking about here from the receipt of the bulk tablets, the release of those bulk tablets, the conversion into a finished good, and then the ultimate release of that finished good will be 2 months. And we're going to assume 100% packaging yield and 100% success rate. So we're going to assume no lost material during this operation. That may be a little bit too aggressive or ambitious for the real world, but you typically would see yields at about 99% and success rates in that same neighborhood. So we can get away with taking an assumption like this. At the bulk manufacturing level, we're going to be talking about 3 months total lead time from receipt of the active ingredient or the API, the release, then the conversion to the bulk tablet, and then the ultimate release of that bulk tablet. So in that case, we're going to be talking about a 97% manufacturing yield and then a 98% success rate. So there will be some active ingredient loss during the conversion to bulk, and we'll also assume that in about 100 batches that are manufactured, we're going to lose 2 due to quality issues. So that's how we factor in kind of our manufacturing success rates. We are going to model batch sizing at this level, so you can see how you would go about doing that. And then we'll get into the API manufacturing step, and we'll there just assume kind of a 2-month lead time for the API manufacturing and release, and we won't get into modeling a campaign strategy.